Hey, grade 5. One of the biggest jumps in difficulty in this year's math comes from the move to multi-digit multiplication. Now, in the past, you've multiplied 1, 2, or maybe even 3-digit numbers by a 1-digit number. This year, we start multiplying 2-digit numbers by other 2-digit numbers, and that can be a lot to wrap your head around. Now, in my class, we talk about 3 different methods that can help you to do this, and students are encouraged to choose a favorite and use it as much as they want. As such, I've made 3 different videos, one for each method. So pick the one you'd like, and we'll go from there. Good luck! This video is for the lattice method. Now, this is the one that I see the most parents complaining about because it looks really different from what we all learned in school. It also happens to be the most popular with students because it does seem to be the most immediately intuitive. Kids love the lattice method, so parents brush up. To use it, we use a drawn frame to help us keep all of our place values organized. It ends up looking pretty awkward and confusing if you don't know exactly what's going on within the frame, so let's break it down with some placeholder letters first to really explain what's happening here. Let's check it out. This is the box we use for the lattice method. Now, when we're using this method to multiply, we start by writing one number across the top of the box and one number down the right-hand side. Our tens from our first number would go here. Our ones would go here. And for our second number, our tens would go here, and our ones would go here. Now, to solve this problem, we simply need to multiply the numbers in the boxes where they meet. In our ones place meets in the bottom right box. That means that the ones place of my answer would go here, and any tens I have from that answer would go here. When I multiply the ones place of the top number by the tens place of the right number, they'd meet in the top right box. Now, if I'm multiplying ones by tens, that means that the lowest place in that would be in the tens place. And anything beyond that would move over to the hundreds. So I'd have a hundreds place in this answer. If I'm multiplying the ones of the number that goes down the right by the tens of the number that's in the top, the same thing that would happen, except now my answer would be going in the bottom left. So my answer here would have a tens place and a hundreds place. Finally, my tens meet my other tens in the top left corner. Now, when I multiply tens by tens, the lower place should be eventually in the hundreds. So I'd have hundreds, and then if I have an answer that goes over into the next place, it would go to the thousands, which I'm going to write as TH because I already have a T. Now, you might be noticing that there's something happening along the diagonals here. And actually, if I add up along each diagonal, I'll get the places for my answer. Adding along this line will give me my ones from my answer. Adding along here would give me my tens. Adding along here would give me my hundreds. And adding along here, which there's only one number, but maybe something carried over, would give me my thousands. Meaning the digits of my answer would be curled around the left of my box. Now that can look a little bit abstract. This was provided more for parents to understand what's happening than for students, because this feels really intuitive for a lot of students. Let's take a break here and look at it with some numbers instead of these letters. Alright, let's try the example problem 24 times 72. Now, for this problem, I've got my two two-digit numbers. And as I said before, I'm going to write the tens for each across the top, here and here, and the ones here and here. 24 times 72. Now I need to multiply each number where they meet. 2 times 4 would go in the bottom right. It's 8. I have 0 tens and 8 ones when I multiply 2 by 4. When I multiply 4 by 7, I get 28. 2 tens and 8 ones. Except it's 4 times 70, so remember, on this diagonal, this is actually 2 hundreds and 8 tens. 20 times 70, 2 by 7. Well, 2 times 7 is 14. In this case, that means 1,400s, but I'm just writing 14 in the box. I've got 1 left, 2 times 2. Hopefully, pretty basic problem for grade 5 is 4. That's 0 tens and 4 ones. Now I just need to add up along the diagonal, keeping in mind that each one comes to a different place value. My ones will end up here, my tens here, hundreds here, and thousands. Let's add them up. 8 plus nothing, I have 8 ones. 8 plus 0 plus 4 is 12. Now this is tricky because I've got 12 tens. That means I've got 2 tens and 100 I can carry over. Remember to carry that extra digit over if you have to. Next, I've got 100 carried plus 200s and 400s makes 700s. And finally, I'm not carrying any thousands over from my hundreds place, so I just have 1,000. This means that my final answer has 8 ones, 2 tens, 700s, and 1,000, or is 1,728. 1728. Curled around the left of the frame. Now this method is especially appealing for students for 2 reasons. The first is that you only ever need to really have your 1 to 9 times tables locked in to be able to do it. It doesn't require knowledge beyond that, and it really makes it clear why this kind of problem is easier than it seems. Second, it does continue to work no matter how many digits you get. You just need to add a new row or column for each digit in the corresponding numbers. Let's try a 3-digit by a 4-digit number just to prove that that can continue working for you. The method is exactly the same, but I need a grid that's 3 by 4 now instead of 2 by 2. Everything else, exactly the same as it was before. Let's see it. All right, I promised you a 3-digit by 4-digit problem, so let's take a look at one. For our 3 digits, let's try 357. For our 4 digits, let's go with 9,200, I don't know, 62. Now, this looks like a lot. And because of the number of digits, we actually have 12 small problems to solve. But none of those 12 problems is any harder than our 9 times table. So it should be pretty straightforward for us. Let's go through one box at a time. 2 and 7 meet in the bottom right box. Well, 2 times 7 is 14. 2 and 5 meet in the box above it. 2 times 5 is 10. 2 and 3 meet in the top right. 2 times 3 is 6. Now let's remember, that's a 6 in the ones place and a 0 in the tens place. I still need to fill in that placeholder. If I don't have any tens, I put a 0 down above the line. Let's just keep moving to the left, zigzag our way around the chart. 6 times 3 is 18 and meets here. 6 times 5 is 30 and meets here. 6 times 7 is 42 and meets here. keep zigzagging. 2 times 7 is 14. 2 times 5 is 10. And 2 times 3 is 6. Last row, pardon me, last column. 9 times 3 is 27. 9 times 5 is 45. And 9 times 7 is 63. If I add along all of my diagonals, going from the top right to the bottom left, I will see each of my places starts to come together. My ones place only has a 4 in it, so my answer is going to have a 4 in the ones place. My tens has a 0, a 1, and a 2, so that makes 3. My hundreds has a 6, a 1, a 0, a 4, and a 4. Now that's a lot, but if you could add it quickly in your head, you'd know this comes to 15. I carry my next digit over. Now I'm in my thousands. 1 plus 0 plus 8 plus 3 plus 0 plus 1 plus 3. It's quite a bit, but it does come to 16. 6 below, carry my 1 over to what is now my 10,000s. 1 plus 1 plus 6 plus 5 plus 1. Getting more complicated as we go, but I think we're through the worst of it right now. That comes to 20. 6 and 6 is 12, 3 more 1s is 15, and 5 is 20. A 0 in my ones place, carry my 2 to what is now my 100,000s place. 2 plus 7 plus 4. Easy enough, that's 13. Carry my 1 over, and my millions place has a 2 already, and that carried 1, which makes a 3 in my millions place. Which means, wrapping around the left, we can see 3,306,534. Now, feel free to double check me with a calculator if you'd like, but I'm pretty confident that 9,262 times 357 equals 3,306,534. Review complete! Now, no matter which method you were watching today, I hope this has been a good refresher for you. Or if this was your first time checking out this method, I hope it was an enlightening experience for you. Multiplying larger numbers is one of the first times that students really stumble with their math, especially in grade 5. But none of it's actually that hard as long as you're comfortable with your 1 to 9 times tables and be careful to follow the steps properly. No matter what your method of choice is, I hope you're better equipped after this to tackle those larger problems. Good luck, guys. Have a productive day. Peace.